In this video, we're going to take a look at the 7 structural design patterns in Java. So a structural design pattern, they deal with how classes and objects are composed. Let's first have a look at the adapter structural design pattern. So the adapter pattern, it facilitates communication between incompatible interfaces. Let's look at the common use cases of the adapter design pattern in web development. So the first would be integrating third-party APIs. The second would be database abstractions. And the third would be legacy system integrations. So let's imagine that we have an existing logger. So let's say we have this simple logger here. And this is what we're using in our current code base, for example. So it just has a method here called loginfo, and it also has a method here called logerror. And that's just done by implementing the iCustomLogger interface here, which has those methods there. And then let's say that we have a third-party logger, and the third-party logger, rather than having the loginfo or logerror, it would have the, say, info method on it and an error method on it. Well, if we want to sort of combine these, what we could do is we could create a adapter. So we have this class here, the adapter logger. And the first thing we do is we create a constructor, and in that constructor we pass in the third-party logger. So we just go ahead and implement iCustomLogger, because that's what we want our methods to be like, the contract. So we have this private final third-party logger that we're just instantiating in the constructor here that we pass in, and then we just go ahead and we can use our interface with the loginfo and logerror methods, and then simply just have that as a wrapper around the third-party logger. So we got the third-party logger.info method when we call loginfo. And what that's going to allow us to do is, in our main method here, for our adapter pattern here, we first create the third-party logger, because we need that to make use of it. And then all we do is we just simply pass it to the adapter, and then that way we can call the underlying methods using the interface that we desire. So let's take a look at that. So let's just confirm that that's all working. And I'm going to just run the docker build command, and also the docker run command. And we see that the third party error, this is an error message, and the third party info, this is an info message. So they're quite clearly coming from the third party methods here. So let's go ahead and close these up and look at the next design pattern. So the next design pattern we want to look at is the Decorator design pattern. This adds functionality to existing objects without altering their structure. So let's look at 3 common use cases for the Decorator design pattern in web development. The first would be using middleware, so request and response wrapping. And I have 3 sub fields of this, or sub points I should say. So you could have that in regards to authentication or authorization. You could have it in regards to logging or error handling, or any real middleware you can think of. You could also have it with decorating views and templating engines, such as caching, or enhancing validation logic. So the example we're going to go with is just wrapping a controller. So you know, in Spring you have a controller, that's where you receive the endpoint. This is just sort of going to simulate that. So let's just say we have this interfacer, iController, and it just handles the request. And it does that for a particular user role. So if we have a look at this real controller, which just implements iController, and real controller just, in place for a concrete controller that you would have, we can see that we simply override the handle request method here. We pass in the user role, and then we just log out the message here and the user role. So if I am to look at the decorator pattern here, making use of that, we firstly implement iController because the decorator needs to conform to the interface. Then we just go ahead and we have a constructor here which we set as a controller when it's instantiated, and we can see here that real controller implements iController, and because of that we can actually have this iController type here and pass that in without any problems. So what we do is we just simply override the handle request here. So we got a little bit of simple thing. We're not actually going to implement the logic, authentication logic, but we just, let's say we just pass in admin. If that's going to equal the user role, then this is going to return true, otherwise it won't be authenticated. So if they're authenticated, we're just going to log out user is authenticated. And then what happens is we are able to use the controller that got passed in here and handle the requests. So this is going to delegate the request to the real controller if it's authenticated in this example here. So let's go ahead and have a look at this. We can see that we create a controller, create a real concrete controller here, which is going to handle the request of the iController type. And we also have a decorator controller. So we use that decorator class here, and then we can pass in that real controller, which has the request is being handled method on it here. So if we go back over here, we can have two cases, for example. So case one, we have the admin user as authenticated. So this will handle the request from the admin's perspective, and otherwise we'll handle it as a guest perspective. So let me just go ahead and build that again. And I'm also going to run that. So here we can see user is authenticated, proceeding, request is being handled, user role. In the second case, user is not authenticated, access denied. So we can see that in the first case, in the case that we have an authenticated admin user, it delegates the response, the handle request method to the controller, and then that controller actually goes ahead and handles the response. So in essence, it's acting as a middleware and adding a layer of security in this case. So let's go ahead and close these up. The next structural design pattern I want to look at is the facade. The facade design pattern, it provides a simplified interface to a complex subsystem. So let's just have a look at some examples here. So it could be used as an API gateway in microservices. It could be used as authentication and authorization management if you have multiple methods here. And also it could be used in messaging system integration. So let's say you have a bunch of things going on, emails, SMS, push notifications. In essence, the facade design pattern, it just simplifies the interface for you to use. So such that when you consume a method, there's a whole bunch of logic that goes on behind the scenes. So this is quite a simple example here. let's say we have a microservice. So we have an order service, which just gets the order details. We have a product service, which gets the product details. And then we have a user service that just gets the user details. So in theory, these would be in their own microservices, but for this example, let's say we just go ahead and instantiate all those in the constructor. And then what we can do, we could have a facade method. So rather than doing all of that in the main method, we sort of have this layer here that gets the full details, and then just gets the details for each of the microservices and just prints out a nice concise message there. So when we're looking at it from here, when we're consuming it, all we need to do is just create the Facade API gateway here. And then the client, it interacts only with the facade, not the individual services. So put in the details here, then you log it out. And if I go ahead and build that, it should be a nice convenient way to just have all of that done for us here. And we can see that it does all of that. So in essence, it hides all the complexity from us. Next design pattern I want to look at is the composite design pattern. So this unifies handling of individual and composite objects in hierarchies. Let's look at some examples here. So we have file system management. So an API for handling files and folders, for example, or menu systems in content management systems, or perhaps permission or role management systems. So it involves hierarchies. So let's have a look here. Let's say that we have a permission component, and this is just going to be an abstract class that we want to extend. But you can imagine that we're doing the example where permission or role management systems. So we could have permissions and then also roles. So in the permission component here, there's just going to be four methods here. So we could add a permission, remove a permission, get the name, and check a permission. These will all give back an unsupported operation, but the idea is that we extend it elsewhere. So if we look at the permission class here, which extends the permission component, we can see that we pass in a name. So, you know, we could have an edit permission, for example, or an add permission. So we pass that in, whatever that will be. Now it gets stored there. And then here we're overriding get name and check permission. So if we want to check that particular permission, we'll just check that the name passed in there is going to be equal to the permission that got passed. So let's get name and check permission, but we also need to add and remove that. And we'll look at the composite role for this. So firstly, we'll go ahead and extend the permission component. So one thing to note is both the role and the individual permissions both extend the permission component, and that sort of allows for that hierarchical sort of nature to it. So let's say we have a role. So for example, a role would be like an admin or editor or something like that. So let's say we're doing a CMS. We could also have individual permissions for those roles. So each role could be composed of permissions. So an admin will have the ability to do all of the things with the permissions. However, you might have like a reader, for example, or like a guest, which might only have permission to just view something, for example. So what we need to do is each role, they'll have a list of permissions that I've called components here in line with the Gang of Four's terminology. So we could have a role, and once again, that has a name that gets stored on that class there in the field of the class. And then we just go ahead and override the other methods here. So add just simply adds a permission to the list. Remove removes it. Get name will obviously just get the name, what it is, and then check permission here just cycles through all of the permissions that that particular role has, and then it'll check if it has it and return true in that case. So let's see how we can consume this. So let's look at the composite method here. Firstly, we create individual permissions. So we're going to have an edit user, view reports, and approve requests here. So we create permissions for all of those: edit user, view reports, approve requests. And then what we do is we create a role for, say, a manager. So we have a manager role here, which is of the type composite role. And, you know, we give it the name manager here. And then on that manager role, we can add the permissions here. So let's have a look at that. So firstly, we just add these 3 permissions that we just created. But if we look at the add method here, we can see that the add method is a permission component here. However, the composite also extends the permission component, so it can be referenced with that type. So we can go ahead and just add those. So let's say we create a sub role for a team lead, which has the subset of permissions. So the manager can edit and view the reports and approve requests, but the team lead role can only view and reports and approve requests. So something that we can do with this composite method, and I alluded to with when I talked about those types just a minute ago, is I can actually do something like this. So I can say add the team lead role to the manager role. So I've got these here, and they'll probably also add these in as well, but you could have a set instead if you wish to have unique ones in there. But you can see that manager role, which is a composite role, I'm actually adding the team lead role to that, which is also a composite. So the permission component here is also what we're extending here, and we can use that type of the thing we're extending as the actual as they'll act as the permission sort of thing. So what we can do is we can just simply check if the roles have specific permissions. So let me go ahead and just save that, and I'm going to run a Docker build. And what we'll be looking out for is we'll see the manager role as the edit user. We'll see if that's true or not by checking the permission. And then we'll also see if the team lead has the edit user, which it shouldn't. But then what we'll also do is we'll print out the team lead has approve requests permissions, and that should be true. So let's go ahead and run that. So as expected, true, false, true. Now let's have a look at the proxy method, proxy structural pattern. So this acts, the proxy structural design pattern, it acts as an intermediate to manage requests to an object. So let's see what that means. Close these permission related things. So firstly, some common use cases in web development. So you could have a virtual proxy for resource management. So this could be useful if you want to delay the creation of resource intensive objects until they're actually needed. And we'll take a look at that example in this video. You could also have a look at, it could also be used for protection proxy for access control. So control access to sensitive operations in a backend service. And a third example would be a caching proxy for data retrieval. So in scenarios where data retrieval from a database or an external API is expensive or slow, a caching proxy may be employed. So we're going to have a look at the whole resource management use case for the proxy design method. And we're going to look at like images. So firstly, let's just create this interface here. Very simple. It's an image. And all it's going to do is display the image. And then let's have a real image, so some concrete implementation of this image. So firstly, when we create an image on the file system, for example, we need to pass in the file name, and then what we can do is we can load the image from it. This is obviously just simulating it. And then we can have a override for the display method here. So if we look at the proxy image, so you can imagine, firstly, you can imagine what we want to do is let's say we're in a situation where we perhaps just saved an image or something like this. We don't necessarily need to retrieve that from the disk and give it back to the user straight away. And especially if we have more expensive operations than that, we can use the proxy, which means we can sort of delay the use of it. So we can sort of have something like this. Let's say we have a proxy image, which isn't a real image. What we can do is we can have a reference to a real image and the file name. So we create a proxy image, which creates something with the file name, store that on the file name field here, and then we override the display. So in this case here, if the real image is null, we can go ahead and load it, because then that's when it'll be needed. However, otherwise it's already there, we can just display it. So looking at the usage of this, looking at the proxy method here, rather than creating a real image, we create a proxy image for, say, image 1 and image 2. The image will be loaded and displayed on the first request. So at this stage, we haven't actually used the image, but when we need to display the image, then we can use the underlying methods. So just to reiterate that, the display here is actually going to, if it's not already there, it will get the real image and then it'll display it. So that's why it's known as a proxy design pattern. So we can go ahead and display the image. So the image should be displayed directly without loading again. And that's if we get image 1 again, and then here's another one for image 2, for example. So let's just build that, and then we'll run that. So here we can see we're loading image 1, displaying image 1, but on the second time we're displaying it straight away. And that's just because there's no need to load it in the second case, because we already have this real image on here. It will no longer be in this use case. Meaning, of course, that we don't need to load from disk, and that happens on the constructor in the first instantiation of it. Okay, so now let's have a look at the bridge design pattern. So the bridge design pattern, it decouples an abstraction from its implementation so that the two can vary independently. So let's see that. So firstly, some common use cases here. It can be used as database abstraction, which is what we'll use our example for. So separating the database logic from the business logic. It can also be used as a logging framework to separate the logging API from actual logging implementation. And it can also be used in messaging systems. So if you're integrating, say, different microservices here, the bridge pattern can be leveraged to create a unified messaging service or interface for the services. So we just have an interface here for the bridge database. So we're going to have a database and the business logic, and the idea is to separate the logic from one another. The database logic from the business logic, that is. So the database logic, you imagine a database, we just want to connect, execute a query and disconnect. Of course, there'll be more things than that on a real one, but let's say we just implement this. So MySQL database has some database logging out here to the MySQL one. Let's say we have a Postgres, same thing, but has a Postgres message there. And then the other thing that we have here is the business logic. So again, we're separating the database logic from the business logic. So the business logic that we have here, firstly, it takes in the database. So it has this bridge database type here, which is what the MySQL and Postgres databases are extending. So we can use that type in here. And then this is an abstract class. So the protected methods can be used on the extension, the subclass. And then we have this method here, perform operation as well. So if we have a look at the product management one, for example, so I'm saying that, we have two different sorts of business logic. So we might have product management business logic that behaves different to the user management business logic. In both cases, we take the database here, the bridge database that is, not the actual database, and we just call the super method because that's what happens in the constructor of the business logic here. And then we just perform the operation. So we, for the product management business logic, we still need to connect to the SQL, whatever database we put in, and then connect, execute, query, and disconnect. And likewise with the user management, we still need to perform the operation. So if we go to the main method here and we create our bridge database here, we have a MySQL database that we create, and then we have a Postgres database that we create, both of the type bridge database, not MySQL database or Postgres SQL database. And then we have some business logic. So in both the cases, we want to perform an operation where we're, say, connecting to a database, executing the query and disconnecting, just for this example, of course. So we create the user management, but we create it as business logic. And what this allows us to do is we can also have the product management business logic, and we just pass in the Postgres database, and we can perform an operation which is done in an analogous way, and it has the same types and everything, but behind the scenes it's so we've got that same nice interface, and we've separated, we can see clearly, we've clearly separated the database from the actual business logic, and we have those common interfaces that look nicely, and we've sort of abstracted this method that does the particular database operations behind the scenes from the business logic. So let's take a look at that. So we'll just make sure that that's all well and good. So we'll do a Docker build here. And then a Docker run. So we can see connecting to MySQL database, executing query, disconnecting, and then connecting to the MySQL. So it's doing all that sort of stuff for us. The final structural design pattern that we'll take a look at is the Flyweight structural design pattern. So what this does is it reduces the cost of creating and managing a large number of similar objects. And it does this by sharing common data, but it also allows for some specific unique data. So let's take a look at that, and I'm just going to close this stuff up. So the Flyweight, some common use cases for the Flyweight design pattern: caching of HTTP responses, text rendering in document processing systems. So let's first create this interface for the session. So I'm going to do it for, say, the sharing of common data across, shared objects. Shared roles. And each individual role might have their own specific information. So you can imagine, like, if you're doing some role-based access control or something like that, there might be some shared common data across the particular role, and then you might have some also unique user-related information. So in this interface here, we have this get common data method, and then we also have this get user role, set user role. So what we can do is we can, actually I need to come to the Flyweight, the concrete session. So the implementation of the session. So we implement the iSession Flyweight that we just saw. And we can see here we got these set user, get user role, and get common data. So these are the overrides here. And then all we're doing is we're saying, you know, you can get the user role and get the common data here. So common data, that's a private field on here. So common data shared among the sessions. And also we have this user role. So the common data is going to be the common data shared among the sessions, as stated by the comment. And the user role will be the unique data for each session. So we can see that when we call this Flyweight concrete session class here, we're passing the common data, and then that's what's going to be common between them. And we're going to need a factory to be able to do that, but we'll see that in just a second. So let's look at the session factory. So what we're doing here is we create a factory to manage the Flyweight objects. So we have various sessions here. So we're going to have a map which maps the common data, the name of it, and the actual iSession itself. So we can reuse the existing session if it exists. Otherwise, we create a new one, and that's what this compute if absent method does in Java 21. So firstly, we have a look at the sessions, and if it's not there, we create a new concrete session, which is this. And if that's not there, if it is there, we just find the key which has that common data there, and then we're able to get it from that hash map. So let's have a look at the user session manager. And I'm going to go over this again. I just need to lay out all of these classes because they all sort of work together. So we have this user session manager. So this has the sessions on it and it has the user roles on it, both as hash maps. So again, we can get the session, and that's going to do the same thing. But we can also set the user role, and they'll get the user roles and then put the session there and the role in there. And then we set the role in the session object. And then of course we can get that as well. So let's have a look at the usage here. So we have this Flyweight usage here. So we create a user session manager first. So, that's this here. So when we first create it, there don't have any sessions and there's no user roles. So then what we do is we create sessions with the shared common data. So for example, let's say user 1, they create their session. And of course, this whole session thing, this is like, you can imagine a user that's you know, if a user that's, you know, they got their details or whatever, perhaps maybe they've signed in or maybe they haven't, but their current, you know, maybe it's like a 30-minute thing that they're on the website and they've established a connection with the website. The browser will be able to tell the back end that there's an actual, you know, it's the same person sort of thing. So that's what we're doing here. So we have a session manager that we create, which is initially empty. But then what we do is we create 3 user sessions. So user session 1, 2, and 3. So for user session 1, we have this user common data here. So let's just take a look at that independently. So firstly, we try to get the session. Now in the first case, the session is going to be empty, meaning we'll need to compute it if it's absent. Otherwise we get it, but it is absent in the first case. So what's that going to do is for this initially empty hash map here, it's going to take that common data, which is just a string, so that's just going to say user common data, and of course that would simulate some sort of user's data, but essentially what we do is for this hash map here, we'll have a key of that user common data, and then of course we'll create a new instance of the actual concrete session itself. So that means, actually I'll get back to that. Then what we do is we set the user role here as admin for user session 1. So if we set the role, we say, okay, user roles, which was initially an empty hash map, you know, we'll put admin as the session. Sorry. Is that right? The session manager set the user role here. So the set user role method here. Session Flyweight. Oh, sorry, I was thinking about this one. Session set user role. So from the user roles, we put the particular session and the role. So the role is the string. I got mixed up here. And then the session, we set the user role. So we set the role in the session. So, okay, so what have we done? We've got the user common set data, and then we set admin for session 1. And then we have this user common data for session 2. And then we have an editor. And then we have this user session 3, which is another user common data, which is going to be different, but still common towards that. But then we have that as a viewer. So the idea is for session 1 and session 2, with the session with user common data, we have that user common data shared, and there would be some shared user data in theory for that particular type. However, we just got the string there, but it suffices for our example. So that would have the common data there, but this would have something different in it for the viewer. But then that's the common data, and since that's on a shared sort of thing, it reduces the amount of total data. You can imagine this would be more useful for, you know, if as you get a larger and larger amount of these objects instantiated, where the user role is the unique thing. So in this case, so what we do is we display the user roles and common data. So when we print this out, we can see that the common data should be the same for user session 1 and user session 2, but different for user session 3. And then we'll also see the user role there as well, which should be unique. And then we have this final thing here, which is this actually demonstrates that user session 1 and user session 2 share the same common data. So we compare the user session 1 to the user session 2, and then they should be equal. So I might just demonstrate that and then sort of talk over it one last time, just very briefly. So, because it's one of those, this flyweight design pattern in particular is one of those ones that a lot of things are working together. So let's just see that. So session 1, role editor, common data, user common data. Session 2, editor, use common data. Session 3, viewer, common data, another user common data. And session 1 and session 2 are common data. So let's see. We have this user session manager here. So in theory, what this is supposed to do is it manages both the sessions and the roles, and if something already exists with the either session or role, you know, it'll use the same object essentially. And we can see that the flyweight, the concrete session, it has the common data that's shared across them. So this flyweight concrete session is the thing that's going to come back. If it's absent, it'll create a new one. But if you try to get the session with the same common data key, it'll return this same concrete session, which means essentially, you know, if it was hooked up properly, it probably wouldn't need, you know, would have unique data here. So yeah, anyway, these are the 7 key structural design patterns. Thanks for watching. In the next video, I'll finish off on the whole design pattern thing, be looking at the behavioral ones